Cobra Golf is set to launch its limited edition 3D printed iron set. June 7th, they come out. They're limited to just 500 total sets, but it's the first of its kind. Cobra Golf is first to market with 3D printed steel irons. And I can't wait to see these. I haven't seen them yet, but we wanted to give you all a look at what goes into making these irons, how they work, how they sound, how they feel, and maybe what's next for Cobra Golf as well. So to do that, we brought in Jose Miraflor, Vice President of Product Architecture and Consumer Connections at Cobra Golf. Jose, thanks for joining me. I'm excited to talk about these because it's so unique. And before we get into what the actual iron is, I kind of wanted to take everybody back a little bit before and look at the technology. And Cobra partnered with NTOP Design Software to make these clubs. How did that partnership come to fruition, and why did Cobra seek outside help to make these clubs?
Well, NTOP is this great small company that has a program that actually makes it easier for us to design these products. So NTOP has this program that allows us to choose between different lattice designs and actually helps us to use CAD to create the lattice structure so that we can create the weight savings, the rigidity, the design of the whole head, whether it's not just the exterior, which is what we all see, but the interior of the head, which delivers all the performance. So we've been partnering with them now for a little over a year, in utilizing it's actually been a little bit longer than that. We licensed with them first, and now we're working on a great partnership with them. We're going to a 3D printed show with them here later on this month, which is going to really show off the irons here in Orange County, California, and we're doing a lot of presentations on stage. So it's going to be a great week in Orange County. But even before them, we partnered with Hewlett Packard to originally start 3D printing way back in 2020. We launched our first ever 3D printed putter, right? That I think we very limited in those amounts as well. We only did like 750 of those putter heads. That was the first ever of its design. It was kind of bulkier, it was kind of bigger, and we knew from there we were going to take off. And we've done other 3D printed things. We have some 3D printed putters that are multi-material today. But to your point that you said, these are the first ever 100% 3D printed steel irons, right? And NTOP is our big partner for this to allow us to create all the performance from the inside out.
And you mentioned the putter. This isn't new. 3D printing is not new to Cobra Golf. It's just this specific set with steel irons. But as you, I guess, put more resources into 3D printing, what's the goal of utilizing that technology? Why is it so important for you to keep utilizing that and keep pushing it forward?
That's a great question. Our goal at Cobra is always to be among the top innovative brands in golf, whether it's CNC milled faces or one length irons or first, electronics inside a golf club, which we, co-developed with Arcos. This is our next thing, right? 3D printing, which we started a few years ago, like we just chatted about, but to continually bring out performance that can only be brought by this additive type of manufacturing and 3D design. Whether you guys know it or not, there's a lot of 3D printed products out there, but never been sold as just a product that you buy. I mean, if you own a Mustang 5.0, your engine block cover, your engine cover for that 5.0 is 3D printed. Your Apple Watches, your little knobs are 3D printed. If you're lucky enough to own a vintage Porsche, those parts, they don't make them anymore. They 3D print them now because it doesn't require tooling, which is a benefit of 3D printing. And I know, Tom, at home, you probably have a Bugatti Veyron sitting in your garage, but all those brake calipers are 3D printed. So and even if you fly in an airplane parts are 3D printed. But there's nothing ever been sold that's 100% 3D printed out of steel. And this iron is why it's so important, right? What we're able to do with 3D printing that you can't do, you cannot forge a lattice because it's a structure inside a structure so complicated. You can't forge that. You can't cast it, right? You can't mill it. You can only make a lattice structure inside a golf club through 3D printing. And that's what makes it so unique. And somebody could say, well, so what? I mean, if you left it hollow, it's you're saving weight anyways, but does it perform, right? In the case of this iron, we're bringing two things together that you don't normally get, right? Everybody in golf would love to, I don't want to say everybody, most people in golf, if they'd love to, would play a muscle back that maybe you played in the past and today you don't have the game for. Or if you're an aspiring golfer, you see all the guys on tour that the muscle back offers the most pure and feel shot and trajectory control. But what it sacrifices is forgiveness. It's not the most forgiving iron. You're going to lose distance if you hit it off the center. You're going to lose control if you hit it off the center. So what we're bringing together here is giving that single digit or maybe even a 12 or 15 handicapper the ability to play an iron that looks like a muscle back, very small, very little offset in this iron, and a look of a muscle back, that type of look, but this shape is smaller than our King Tour. So it's smaller than the iron that Ricky Fowler plays, but it's got more forgiveness than our Tech X, which is our super premium game improvement iron that offers easy up and high for stability. This iron is more forgiving than that. And you don't normally combine those two, right? So if we're able to do that, and you can only do it with 3D printing, that's an advantage. That's something that you can offer to a golfer who's looking to pay for more performance in their game.
So how does 3D printing allow you to do that? Because this is the first blade design with the MOI of a game improvement iron.
Right.
How does 3D printing allow you to do that?
Well, I think it starts with the shape. So we start with the shape. That's really cool, right? I'll hold it closer to the screen so everybody can see it. It's a small shape, right? It's not very thick sole. It's got very little offset. But when I turn this over and show you what's on the inside, you're going to be like, what the heck is that, right? This is a 3D printed lattice structure that saves all the weight from the center of the head. We're removing 100 grams of weight. And we're not doing that to make the face flex more. It's true. The reason why muscle backs and muscle back cavity or muscle cavity backs, excuse me, sound so good, those forgings, is they're a very rigid face. So there's not very much face flexion, and a lot of vibrations move up through the top line and up into the hosel. And that's what gives you that smooth feeling response, right? Well, we wanted to do that even though we're doing a lattice structure. So these lattice structures are actually very thick. I'll show it to you again. They're very thick, and they're saving the weight from the middle, but they're adding rigidity. So this flexes like a muscle back, or like I should say, doesn't flex very much like a muscle back. What we're able to do though is save that 100 grams of weight and put tungsten on the heel and toe of this iron. 100 grams positioned really low for low CG. That's going to give you more speed in itself. It's going to give you more launch. And because we're putting 100 grams or roughly 50 on each side, heel and toe, it's going to give you super stability when you hit it off center. So now you have easy up and you have super stability in a small iron, only because you've been able to save the weight from the center without causing any flexion. That's how you keep the feel. And you're able to combine all that to create this super iron. Here's another look for you of a cross section of an iron. I'm not sure I think the camera can pick this up pretty well.
Yeah.
That's what this cross section looks like. So you can see that it butts up all the way to the face and all the way to the back of the iron head. Here's the other half of it where we cut off. You can see the hosel that I'm holding, and you can see all that lattice structure. So even though you can see this lattice in the back of it, there's a back wall to that, so you can't get any debris inside your head or water inside the head. It's a solid structure. We even have these cool little 3D printed lattice structures inside this clear iron. So it's a lot easier to see if you were here. So that's why I brought so many different samples so that I could show you guys on camera, because without us being in person, it's hard for you to see. But as you can see, there's a lot of technology that the engineers have been able to put into this. But this has been a 3+ I want to say 7-year plus venture investigating 3D printing and getting us to this level. And we're going to continue to bring out the next level of 3D printing that you guys can start to imagine. I won't give away that we can do based on the technology you're seeing today.
You mentioned the feel a little bit there. I'd love if you can touch on the feel, the sound, if we're going to have the workability of a blade, how that differs, and durability. If you look at this is as such a new idea or technology in steel irons, I think all those factors are probably going to be important for golfers as well. How does it compare to you mentioned either casting or forging irons in the past? How does that compare now with the 3D printing?
You know, it's incredible. If you I can go back now because we have a lot of reviews on the irons from both our tour staff, our staff in here, our testing staff, and even now people out there have been trying the iron. If we had stamped forge on here, people would say, yeah, it's forged iron. It's not, right? It starts with a powder, which is about the consistency of powdered sugar. It's a 316L steel powder. And the way it works, Tom, is like your inkjet printer, the printer passes over a pad and lays down a thin layer of powder, and we laser sinter it to harden or fuse the powder that we want to fuse together to come together and harden. And it'll pass another time and lay the next layer on. And it goes for a whole day, 2,600 passes of powder laying and laser sintering. And it starts from the toe of the iron and it works its way up. When it's done, the powder that's not been laser sintered or hardened or fused is whisked away and recycled. And all the other irons that have been done, we can do up to 32 on a plate, are done. And we now can cut those off and we begin to polish them and chrome them and put the grooves in, all that stuff. But that's how long it takes. It's 2,600 passes in a day for a printer to do 32 irons. The beauty of it is we don't have to make any tools. So when we were investigating this, you can imagine we can make 32 different renditions of the same iron at one time. That's the benefit. But the beauty of it is now you have this iron that's perfect. It was steel powder, now it's hardened steel. The question you ask is, how do we develop the feel? The feel has to be soft, like a forging. Without that, we're not going to get tour players to try it. And right now, Ricky's been trying a set, Justin saw, we have this guy named Matty Schmidt on tour. We have a bunch of our advisory board guys. They've built them all sets. They're all in play. The guys are like, these are the coolest irons I've ever tried. Like I said in the beginning, the lattice structure here is very thick. So it's made to make the face not flex. So it's rigid. So that's why it sounds like a muscle back or a forging or a forged cavity back. Your purest forgings, this iron sounds just like those. That's step one. Step two, you asked, how do you make it workability wise? How does that perform, right? Of course, we put our standard grooves on, which are, you know, some of the best grooves in the marketplace for controlling ball spin and trajectory. But then we're also utilizing what we know about modal technology. So how thin the top line needs to be, how little offset, how long the hosel is to give you not just the feel, but for the sensation of the player to be able to time it up such that they can work the ball. So that's very important to us. So we built that into the club. The size of the club, you know, we wanted something that fit in our tour caliber of MB, CB, King Tour. So this sits in between the CB forging and the King Tour, a little bit more compact than the King Tour in the toe box, a little bit lower, a little bit shallower in the top line, in the toe area. So this iron is compact. Now, is it as small as a muscle back? I would say no. But it's compact enough that a lot of tour players, I think when they get their hands on it, are going to be very interested in this iron and how good it feels. I know that a lot of the performance that we're seeing both on robot and in player testing has been incredible. So we're not worried about when somebody says, hey, that's a $3,000 set of irons. They better perform. We know it's doing that. So we're excited about that.
You mentioned some of the tour guys that are eager to use them. What type of golfer, what profile fits this set of clubs? It seems like it might widen the range of who can actually use this because of what it can do.
Yeah. You know, I would say that can't give away everything, can I? I would say that this is made for guys who are two handicap tour, if some of you tour guys would like it, and up to, I'd say 12, you know, and if that person is looking for something there's a couple different guys in there, right? That's a broad spectrum already, right? Because if you're a two handicap or a scratch golfer, you probably say, well, I hit in center a lot, so I don't need a lot of forgiveness. But hey, when I do, it's nice to have some irons that give me that, right? There's nothing wrong with constant distance, right? No matter where you hit it, it goes the distance, right? Or goes in the general direction that you want to go. That's valuable to any type of. Now you get to the 10 handicapper that says, you know what? I hit quite a few greens around too, but you know, on those occasions when I miss it, I always come up short or short left. You know, it'd be nice to have an irons that I can depend on. So on those days I'm not very good because I am a 10 or a 7 or a 12.
Those days can be often, right?
Those days come more often now for me than the other side where I'm playing great. So yeah, so that's great to have. So it's hard to say. I will say that the feedback, and this is both good and bad, from Ricky and Justin is the CGs are so low on these. On the short irons, they seem to fly higher than the window than they want. So with the tungsten being placed so low, their CGs are too low for them, so the windows are flying high. They don't want to strengthen the lofts to bring it down because that makes it go even further. So what we can do for them is quickly develop CGs that are a millimeter, 2, 3, or 4, or 5 millimeters higher, so we can determine the perfect CG height for Ricky or for a Justin. We got to develop for them the right CG locations, both up and down, for them to thrive with the trajectory they're trying to hit, right? They're better than most of us. They know the windows that they're looking for. I would say for most of us who are getting to these irons, the lower the CG, the better, because lower CG means more transfer of energy, more ball speed. And it also means easy up, which we can always try and flight down. It's a lot easier to flight down than it is to flight it back up. If you're a low ball hitter or just don't have enough speed to get the trajectory that you're looking for, you could use lower CG.
Yeah, I think all of us non-tour players will always take more distance and more help getting the ball in the air. You mentioned this is not just a 3-year process, it's been almost a 7-year process. So what does this mean for what's next? I know you can't give away any secrets, but how does this change the game? And what is next coming for Cobra in terms of 3D printing, or what technology will be utilized in the future?
Well, I think it's the first of its kind. It's not a first for us. You know, we had a tour player who is no longer with us, but we made him 3D printed products back in 2019. Kyle uses a 3D printed utility iron. That's his 300-yard club. Wouldn't it be nice to hit your 3 utility 200 yards? I mean, 300 yards? That'd be great. For him, this is where we learned at the fastest speeds, we had to add rigidity, right? Because he could break every iron that we make that's hollow in 5 hits. So we've been working on 3D printed irons now, whether we're adding rigidity or utilizing it for speed of design, whether it's putters on tour or whether it's irons for our different players that we have. And you know, now we even use 3D printed wedges. And you would say, well, what would you do 3D printed in a wedge? Well, imagine once you get a grind made for Ricky or Duff or Justin, and they like the grind that they have, there's no better way to repeat that grind instead of trying to emulate it every 3 months when their wedges need to be changed. But if you just take it and scan it and put it into a CAD design for 3D printing, now you don't need any tooling, because tooling takes typically about 8 weeks to make for forging or a casting. We now just send it from our printer to to, excuse me, from our CAD computers to a 3D printer, and they can make 30 of them. And now Ricky Fowler has 30 lob wedges with the perfect grind that he and Ben designed together. And we can just pull those, and they're easy to do. Another benefit of 3D printing, right? Repeatability, and without the waste of time. So there's so many applications to this brand new manufacturing technique. It's open-ended. So you could go hog wild about thinking I mean, for you, my friend, we've never played golf together, but you may have tendencies that you could say, man, it'd be great if we can design me an iron that caters to my tendency and makes my miss hits better and my pure hits even better. That's something you could do with 3D printing if you have the ability to analyze what people's swings need, right?
I'd play a lot of golf with you if you were able to figure that out. That'd be awesome. Well, that was a lot of information. It was a lot of great information that we packed in there. It gave everybody a good look at what's to come with these limited irons, the first of its kind 3D printed irons from Cobra Golf, set to release June 7th, 500 steel 3D printed irons coming out. Jose, thank you very much for joining us.
Thanks for having me, Tom. Take care.